I've put together this video to help you review for your test coming up Monday, November 12th. In this video, we're going to go over what the test covers, and some of the things we'll go over pretty quickly. If you need to take a second look at it, go ahead and pause the video and you can write things down or review what you need to review. So here's what's going to be on the test. Chapter 1, Lesson 3, 4, 5, and 6. Here are the terms from Lesson 3. There's a few definitions I've given you. A lot of these are straightforward. We're going to talk a little bit more about the terms of law of universal gravitation. So with the law of universal gravitation here, what we're talking about is what Newton came up with, and they say that force of gravity depends on mass and distance between the objects. So there's an attractive force of gravity between any two objects in the universe, but the strength of that attractive force depends on the amount of mass of the objects, each object, and the amount of distance that's between them. So this graph right here kind of goes over, it's graphing gravity and distance, and see how the force of gravity is affected by the distance. You should be able to understand this graph and read this graph to answer these questions over here. Let me just go over this graph right here. The unit is distance from planet's center. So all that's saying is that if the planet's center is right here, right, the distance starts off as a unit of 1 radius. So it's saying that the distance is however far it is from the center to the edge of the planet. That's your distance for 1. Right? So this is the amount of gravity on the surface of the planet. That's 1 radius away from the center. Then they say for 2 radius away from the center, you take this distance again and you put it right here. You line this up again and you say, well, if that's 1 radius and you double it, that's 2. And then, so you're talking about this distance away from the center, 2 times the radius away from the center of the planet. Then, of course, now we go to 3. Same thing again. We put another one of these lengths over here. Now we say we're 3 radii away, etc. There's 4. All right, so that's what this graph is saying here. I get a lot of questions about this graph. Next, here are the answers to the questions. It's also important to look at this relationship over here, all right? Because if you decrease the mass by a factor of 2, you divide it by 2, you get 1/2 the gravity, all right? But if you if you change the distance by a factor of 2, you get 1/4 of the gravity, all right? So that was telling you here that distance is the bigger factor when it comes to when it influences gravity. So distance is going to have a more immediate impact than changing the mass. All right, the next one, gravity and motion. We've talked a bit about mass versus weight. All right, here's a straightforward definition. Mass is just the amount of matter. Right, that doesn't change. If you go from the Earth to the moon, you still have the same amount of matter that makes you up. You still have you know, if you still have 10 fingers and 10 toes, you still have the same things that you started with on Earth. You took all those with you to get to the moon, right? Once you're on the moon. But your weight is going to change. Weight has to do with gravity and the force of gravity on the matter. So the more matter you have and the more gravity there is, the more weight there'll be. We did go through this some before, so I'm not going to spend too much time on reviewing it. Next, this mass measured with a balance, right, whereas weight is measured with a scale. Right? Normally we call it a spring scale, but any scale has a spring in it, whether or not you can see that spring. Most of your bathroom scales, the springs are kind of out of sight, and they may not look like traditionally what you think of as a spring, but technically they are springs. Then inertia. Inertia is pretty much the same thing as mass. There's a little tiny distinction, but essentially the more massive an object is, the harder it is for you to change its motion. Notice we say change its motion. We don't say set it into motion. We say change its motion. And it's very important. It's a subtle difference, but a very significant difference as to why we don't say move it or get it into motion, we say change its motion. And that's kind of coming out a little bit here in Newton's first law. In Newton's first law, it says that an object at rest will stay at rest, and an object in motion will stay in motion unless acted on by another force. So if the object is still, right, and its inertia, it has a lot of mass or a lot of inertia, then it takes a big force to get it moving. But likewise, if the object is already in motion and it has a lot of mass, it takes a lot of force to stop it, right? So that's a change in its motion, slowing it down. So I like to talk about bowling for this one. So if you've got, this is why you don't take one of the dodgeballs that Mr. Holmgren gives us and use that out in the bowling alley, right? It doesn't have a lot of mass. So once you set that dodgeball in motion, right, it doesn't have a lot of mass. It hits the pins, and it's just gonna stop. It's not gonna knock any of the pins over, right? Whereas a bowling ball, it has a lot more mass. It has a lot more inertia. It's harder to stop that bowling ball's forward progress, so it can knock those pins over, right? Also, when you're riding the train, right, and the brakes go on suddenly, and you tend to keep going forward. You might bump into the person next to you if you're not holding on tight to the railing. Okay, next, in class, I did an activity, or I did a demonstration where I just took the string and swung the string around my head, right? And at the end of the string, though, we put a weight. So we took some string, put a weight on the end, and then swing that weight around and around and around, right? That's kind of like orbital motion. There's a path that weight follows as it goes around my head. And that's similar to what's going on with the orbit of a moon around a planet, such as our own moon. There's two forces at play here. So you should know with orbits, you should know that you're dealing with gravity and inertia. You should know the role that both of those play. If you change either one of these or take either one of these away, your orbit will not stay the same, right? If you take the inertia away, the body, whatever it is, will be pulled by gravity down into the planet, right? If you take the gravity away, right? Think about swinging this around here, around your head, and you saw all of a sudden you go ahead and cut this string. You take the gravity away, that's going to send your body, the weight, flying off in whatever direction it happens to be heading in at the time. So here, the moon would go off in that direction. If the string were a little bit further along here, and you had your weight here, right, and then you cut the string, the inertia would take it off in this direction. So here, right, as the moon is following this circular path, it's important to understand that both these forces are combining to create this circular path, and that if you lost either one, the orbit would no longer exist. All right, so that was lesson 3, a brief overview. Again, this is just review, so I'm not going into too much depth. Lesson 4, I'm going to do another PowerPoint on here. Lesson 5 is the tides, and that's a separate video that I sent you the link for. Lesson 6 we'll get to in this movie. We'll continue with that. So let's now go ahead to moon phases and eclipses. This is lesson 4. All right, so with your moon phases and eclipses, a couple things I do want to point out. These are the terms I want you to know for this lesson. Right, these terms. Now these 4 right here are mentioned in your book, but they're not explicitly defined in your book. You do need to know the definitions for those. You do need to be able to tell me all of these things right here. So you can pause this and go through it. When you're studying, don't just say, oh, I know that. When you're studying, actually write down the answers. Right? I say, well, you need to know the cause of the moon phase. Be able to write it down. And in your studying, you should write it down. A lot of times I get people, they're just studying, they think they know it, they feel pretty confident about it, but then when it comes time to write it down, then it becomes clear that they still have some questions and they might need to study a little bit more. All right, let's go through our moon phases. Here we've got a new moon, it's darkened. Then the then you'll notice that as the moon orbits around Earth, um, you're going to have different parts appear to be illuminated, right? So you start off in a new moon, you kind of have this arrangement here where you have the sun, moon, and Earth. Then, and the side facing the sun, the half of the moon that's facing the sun is always illuminated. Here in this arrangement, you can't see any of the illuminated half, right? So that position is a new moon. You still have half the moon illuminated, but you can't see any of that illuminated half. As the moon travels and its position relative to the Earth and the sun changes, you can start to see a little bit of the illuminated half, right? So from Earth, if you're standing right here, you can see a little bit, that little bit of the illuminated half right there. And that's this right here. That's our waxing crescent. So remember, waxing means getting bigger. Crescent means a shape. It describes a shape left in half a circle. In your waxing phases, you get the right side that's illuminated first, right? Your right side gets illuminated, and that grows. It's bigger and bigger and bigger. The waxing phases are as the visible portion of the moon grows. So this is also a waxing crescent. You get your first quarter, and it continues to grow. This is a progression. It gets a little bit more each day, and even hour after hour, a little bit more, a little bit more, a little bit more of the moon becomes visible during the waxing phases. All right, then we go to a full moon. Then we have our waning phases. In the waning phases, the left side is illuminated first, and the right side is in shadow, and that shadow is growing. So here's waning gibbous. You've got more than half illuminated. All right, then we're going through our waning gibbous. We get to our third quarter. So I'll label that for you. Third quarter is the name of the phase. Then we go to a waning crescent. All right, and then we get back to where we started with a new moon. So those are your phases. It's important to understand what's going on during these phases, and then understand that if you're observing this from the top, right, and you have the Earth here and the sun here, you can draw in, and I'll probably have a diagram on the test where you have to draw in what the moon looks like from Earth's perspective at different places in its orbit. All right, so in this, the moon would be totally shaded in here. This is what it would look like from Earth. Here, the right side would be illuminated. This is what it would look like from Earth. So you have to be able to draw these in. The other thing to consider is that in the lab activity, right, when we did this, the activity where we had the overhead projector and that light shining out, and then we stood out here in the classroom with the styrofoam ball on the end of a stick, and we rotated, revolved this around our head, right? You should understand what we were doing that and what the result of that was. When we did that lab, the diagram actually had the sun at the top of the page, right? Had the sun up here. So you should be able to understand how the location of the sun affects what it looks like from Earth. Right, so on the test, I might put the sun over here on the right. I might put the sun over here on the left. I might put the sun on the bottom. So you should know how the location of the sun affects which one gets filled in. All right, so for example, if the sun is on the bottom of the page and the Earth is here, right, then your new moon phase is going to be here, and your full moon phase is going to be here. And you're going counterclockwise around here to and the right side is illuminated. All right, so you get a waxing crescent. Right, so the perspective matters, and this is a full moon up here. All right. The other thing is that you should know the amount of time for these. We talked about two figures. We talked about the 29.5 days, right, equals one lunar cycle. All right. And from that, you should be able to figure out, well, if that's one lunar cycle, and I ask you, well, how long does it take to go from a new moon to a full moon? You should realize, oh, that's half a lunar cycle, so that's going to be half of 29.5 days. So you should be able to calculate that, like 14.75 days. The other number is 27.3, and that's the number of days. That's the number of days for the moon to go 360 degrees around Earth. And I would be able to answer some questions about why that is, right? There's a discrepancy. You took some notes on that. We talked about it a bit in class. I'm not going to go over it right now, but it has to do with the fact that Earth is continuing in its orbit around the sun while the moon is orbiting around Earth. All right. Next, let's go up to a lunar eclipse. Right? Most people are pretty good about the arrangements of the sun, earth, and moon during a lunar eclipse. So here you have a lunar eclipse, you have the moon in Earth's shadow. Now anybody on this half of the Earth could witness the moon passing into the Earth's shadow. So lunar eclipses are witnessed by a lot of more people than the next event, which is the solar eclipse. The solar eclipse, the Earth goes in front, or the moon goes in front of Earth and casts a shadow on Earth. The moon is relatively small, casts a relatively small shadow. So it's witnessed by many fewer people. And depending on the population center, it might be witnessed by very, very few people. So it might pass over a point on the ocean. The shadow might be an ocean. Now there are people who are like seeing this kind of thing enough, and they spend the money to go out on a cruise ship. So you might have a few people witnessing it, but it might not be that many people who witness the solar eclipse. Why eclipses don't occur every month? This has to do with the tilt of the Earth's or the moon's axis, or the moon's orbit around Earth. I'm sorry. The moon does not orbit on a perfectly on the same plane as the Earth orbits. It orbits more on a tilted plane. So it orbits more on a plane like this. So most of the time when it's a full moon, the moon is either a little bit above the Earth and it casts its shadow above Earth, or it could be a little bit below and it casts its shadow below. Now your textbook and other textbooks can be deceiving because a lot of times they draw it out something like this. They show the sun and you've got the Earth and the moon relatively close, so it looks like there's this giant shadow and you should be having eclipses all the time. But in reality, if you were to do this with a little bit more of a realistic scale, right, and you draw the Earth this big, the moon is going to be 30 Earth diameters away. So, and it's tilted. So you're going to have, and this is just an approximation, you're going to have the moon way over here, right? So you've got this shadow is tiny, it's being cast off into space, right? So it's becomes a little bit easier to understand why this event is so rare and doesn't happen every month. All right. That is our basic review of moon phases. Write down any questions while you're watching this so that I can help you out with that. Then lesson 6, I'm not going to spend too much time going over lesson 6. These are the terms over here on the left. We've got the terms from lesson 6. Highlands is not bolded, but it is in there. It is included in your book. You should know that, even though it's not a bold term. Concepts to know about the moon. A lot of these things like density, temperature, and composition, we need to know those things in relationship to Earth. I don't need you to give me a value for the moon's density, but you should know how dense the moon is compared to Earth. You should know temperature swings compared to Earth's temperature swings. You should know the composition of the moon compared to composition of the Earth. Then we've done a bit about the origin of the moon, the theories about the origin of the moon's atmosphere. That's pretty simple. There is no atmosphere. You should know what consequences there are for that. We talked about that a bit in class. And you should know a little bit about water, where there possibly is water on the moon. And there might be a question in there a little bit about why water is found where it is on the moon, or why we think there's water where it is on the moon, right? And this has to do with, remember, there's no atmosphere on the moon, so that causes there to be big temperature swings. So it gets really hot and really cold. So any water that's on Earth, on the moon's surface in the form of ice, when it's really cold, would melt and even turn into a gas. It'd be vaporized, turn into water vapor. But the water vapor, right, it moves around. And there's not enough gravity on the moon. There's not enough gravity between the moon and the water vapor to keep that water vapor there. So the water vapor can go off into space. So it's thought that in most locations of the moon, if there was water there, it would have evaporated and then been lost to space. There's one big exception to this, and that is places on the moon where the sun never shines. And that would be at craters near the poles. So at craters near the pole, you could have potentially a pit, right? And at the bottom of that pit right here, you might have a setup where literally the sun never shines, right? So you could have ice, water ice existing in that location. I'll go ahead, write down any questions. Let me know if you have questions, and good luck with your studying. Again, be sure that you can write these things down. Don't just say, oh, in your head and say to yourself, I know this. Write down that the temperature swings on the moon are much bigger than the temperature swings on the Earth. The Earth has a smaller range of temperatures, but the moon will get much hotter and much colder than the Earth. Right, so you should, when you're studying, you should actually have a sheet of paper next to you and be writing these things down and testing your knowledge.